All right, everybody, welcome back to I don't know, week 6, and we're going to finish up module 3 this week. We're going to do 3.3 to 3.7. We've already covered Boolean values, conditional execution, loops. I don't know if we touched on lists last week or not, but we're going to do lists, list processing, and some logical and bitwise operations. Again, this is another kind of meat and potatoes week, so pay attention because you'll need this stuff in the future. The assignments are, you got 3 labs to do in Cisco. Send me the screenshot, and I'm giving you 1 project to do in PyCharm, and we'll cover that in a little bit. For right now, let's jump into lists. Let's see if I remember everything. So that close up. So a list is a variable like any other. You can give it whatever name. Well, obviously you can't put a semicolon. As long as it adheres to the rules, isn't a keyword. Keep it simple. I'm going to call it list. You do a little equal sign, and then it's a square bracket, and whatever's in that square bracket is the list. This right here is the correct declaration of a list variable. The list just happens to be empty. And we fill it by putting data in there. 4, 5, 6, 7, 8, 9. What's important to remember about lists and how the computer counts. I may have mentioned before, or you should have read, that the computers start counting at 0 and humans start counting at 1. So this looks like it's numbers 1 through 9, but how we address each one of these, we use their index number. And that's going to be the computer counting from 0 to 1. So if I wanted to print just one of these numbers, I would have to do print, and it's going to be list and the index number. So if I put the index 2, I'm not going to get the number 2. What number would I get? I'll play like Dora the Explorer, and I'll look at you real funny, see if you can get the right answer. But if I run this, you'll see that I get the number 3 because it is in the second place. Well, really, this is in the third place, but we start counting 0, 1, 2. So that is how I would print that second thing. If I wanted to print 2 to 7, you put a little semicolon in there, and it will print from the 2 place to 2, 3, 4, 5, 6, and 7th place. No, it excludes that 7th place, so everything before the 7. It is not 7 inclusive. I hope that makes sense. That's more of a... So it starts at the 2nd place. You can see we have the 3 in there. That's in the 2 index. We're telling it to go to the 7th index, which would be the number 8. But it does not include that index. It only gets the one just before that. If we put in here like a -1 and run it, we'll get everything to the 8. We will not get that last one. So you can do like a negative index from the end. If I do -2, it'll get me 2, all the way to 2 to the end, however long it may be. That is something to remember. You may use that in the future. I'm going to touch on this real quick. This is a list, and within a list variable, I can have a list of lists. And this gets confusing, but if I put in here another list, 1, 2, 3, and I'm going to keep it short. So now I have, I got to put, and you have to put parentheses on either side. So you can see that if you can see my screen, what's highlighted right now, they're kind of yellow with the blue around it. That is the square brackets for the entire list variable. Within that, there are other lists denoted by those square brackets. You have the 1, 2, 3 list, and then a comma, and then the 1 through 9 list. Both of those are separated in brackets. So this is what we call a multi-dimensional list. I like to call it an array because most of the other languages call it an array, but some people would argue that Python doesn't have arrays. I don't know. You decide. So instead of when we wanted to print, if we want to print an entire list of one of these, so before, if I had just print list before, it would have printed the whole thing 1 through 9. If I print list now, just list, and run that, it'll print both of them. So if I want to access just one of the lists, I have to put, so we have 2 lists, 0 and 1. If I put 0 in here, it'll print the 1, 2, 3. Oop, I'll put a plus in there. So it just prints the first list of in that list array. But what if I want to just have it print 2, the word 2 right here? I have to give it an additional index of 1. So the first list and the second variable in that list, and it'll print just the 2. And that's how you address a multi-dimensional list using the indexes. We'll get into that a little bit more when we start the project. Some logical operators, and, or, and not. Those things are common in all programming languages. And so this kind of comes back to conditional execution. You want something to happen if this happens. What if you want to have 2 conditions? And if this happens and this happens, or this happens, or you can say you want this to happen if item 1 happens or item 2 happens. That probably is best described using if statements. So if 1, we're going to do a few things. This may be a little complicated. If 1 is in list, we'll print 1 is in the list. And otherwise, else, I'll just make it general. So let's do this. The search term, because we're going to change it up. The search term is in the list, or the search term is not in the list. So if the string 1 is in the list, I may have to put this in a variable. Let's run this and see what happens. Maybe it breaks. Nope. It says the search term is not in the list. I feel like that should work, but let's try this. It is in the list. So we have to specify which list in the lists. Oh, you have to count twice, that's why. We'll get to this in a second. Let me go back to what we were doing. Just a single list. It'll make it less confusing. All right, so now we just have one list, and it's 1, 2, or 3. So if I run this, it says it is in the list. Let me make this capital so I can tell them apart a little bit easier. And if I'm looking for the number 4, if 4 is in the list, it's going to print it, and it's going to do the same thing. And you can see this one's not in the list. So it searches the list for this variable. And a lot of times what you'll end up doing is having a variable with that definition, and then just putting that variable name here. This works as well. But if we want to have 2 conditions, we need to use and. If, no, that's not and. And let's just do 2. I'm keeping it simple. Trying to keep it simple. If 1 is in the list and 2 in lists, I don't need this anymore. We'll say the search terms are in the list, or same thing. So we'll run this. It is in the list. But if I put if 1 and 4 are in the list and I run that, search term is not in the list because 1 and 4 are not in that list. But if we want to do an OR, so this will look for 1 or 4, and it should, because 1 is present, it'll say it's in the list. So it is in the list. So it's looking for either one. With an AND, both conditions have to be met. With an OR, it can be either one of them. It's pretty simple. And then we can do NOT. So the last one is NOT. If 1 is not in the list, you got to flip these, but I don't feel like typing it. So it's not in the list, it's going to be opposite. It'll say it is. And if it is in the list, it'll say it's not. So it's saying it's not in the list, which means it is, because I just didn't flip these. But if I do 4 here, 4 is not in the list, it's going to say it is in the list. And that's how you get your conditional statements to work with more than one if. So if you want to meet 2 conditions, or 3 or 4 or 12, you can do that. And those are logical operators. Bitwise operations. So, all right, we're going to get a little complicated here. I'm hoping that maybe you've had some other computer courses that have explained how to read binary and what the computer is looking at. Because we're going to have to compare strings, and I just want to make sure that you understand what the computer is doing. So here's a little PowerPoint. This is something that you're going to see in one of your labs. I'm not sure if this is one that's actually due or not, but it is one we're talking about. So we're going to be comparing strings. And let me back out a little bit. You'll see this when you do your homework if you're not getting a good view right now. But down here, we are looking at this alpha. I'm sorry, I'm circling on the wrong screen. This alpha, remember we learned this is equal to, so alpha is equal to alpha. And you can see these are clearly the same. So this would equal true. This would be true statement. And alpha does not equal alpha with the capital A. That would also be a true statement. But why? They're the same word, but you can see that obviously clearly the capital A and the lowercase a are not equal. Why is that? We also have down a little further on that same homework assignment, alpha is less than alphabet. That is true. And then beta is greater than beta. This is true. And I think this is one that gave me the most heartburn, because everything else makes sense. I get lowercase alpha is not equal to uppercase alpha. Not equal to, but now we're saying that the lowercase beta is greater than the uppercase beta. And that gave me some pause. I was like, well, why is that? So I wanted to make sure this was clear with you guys. We're going to talk about this stuff. This is in your book. It's telling you here, you know, say you have I is equal to 15 and J is equal to 22. This is the binary. This is the ones and zeros that make that true. And let's just look a little bit closer into that. Okay, so I is 15, J is 22. Here's the binary. They're stored with 32 bits of information in memory. And the bitwise image of that is just like this. This is how it's stored in memory. The ones and zeros are positive and negative charges. So we can see that J and I have some ones in different places. The zeros mean nothing, but the ones are counted in a frame of 128 bytes, and I'll try and make that a little clearer. We break it into 4 sections of 8 bits, and all these bits that are 0, they equal 0. There's nothing there. So the first 3 sections equals 0. That's pretty easy to understand. The next section we can see here, and this is what I was talking about, the 128. When you break it down into 8 bits, this is how you count them. The first one on the right hand side is equal to 1. The next one is equal to 2. The next one's 4, and they double, and so on up until 128 for 8 bits. So while all the zeros always equal 0, this is 8, 12, 13, 14, 15. And that's how you get 15. That's why I is equal to 15. And this is how it's stored in memory. With the J, same thing on the first part. And then we have a 1 in the 16 place and a 0 in the 8th place. So 16, 20, 22, yeah, and a 0 in the 1. So that's 22. J was equal to 22, right? Yep. So that's how it's looking at things, and that's how it compares strings or numbers. So when we get back to this lowercase beta is greater than uppercase beta, I'm going to refer you to this sheet. This is the decimal, hexadecimal, octal, and characters and their values. So if you look on here, and we need to find the character for the uppercase B. You can see my little cursor moving. The decimal place for that, the decimal value for the uppercase B is 66. But if you look to its right, you'll see the lowercase b, that decimal value is a 98. So when it's comparing those strings, it's not looking at the text, it's looking at these numbers. The hexadecimal, the octal, and the regular old decimal, they're all higher, therefore giving the lowercase b more value than the uppercase b. I'm not sure how this list was compiled. They may have just started, okay, we'll start with capitals and then go with lowercase. Maybe they didn't intend it to be that way, but that's what it is. So when you compare strings in Python, this is what it's doing, and this is why it's doing it. And you can, I don't know if I provided this chart or not for you, but you can certainly Google it and you'll find this hexadecimal, decimal, hexadecimal, and octal chart. Oh, there it is. The source is lookuptables.com, right down there in the lower right-hand corner. So you find this table. I'm not sure it'll come in handy. I guess it'll come in handy depending on what you make your programs do. You may or may not need this. I'm not sure I've ever needed it except for class. But it is important to know how you do it. And then if, I mean, this is how you read binary. If you recognize, if you can pull everything down to the 8 bits and recognize the bytes in there, then just memorize the table and figure out that, what was 22? No, 22 is a synchronous idle. Never mind, that has nothing to do with nothing. These were, the example I gave you was how it was storing a number rather than a digit, but it relates to how the digits are, or the text strings are seen and compared to each other. I'm going real fast through this because I know nobody wants to watch a 30-minute video, and I apologize. But if you have questions, please let me know. So you will see, okay, one more thing. You're going to see the -1. You're gonna do some indexing. You're going to have to remember how to index the lists for your labs. You'll see the -1. You will learn, we're going to do append, insert, delete. Trying to make sure I cover all my bases here. All right, so let's go back to our list. 1, 2, 3, 4. I want to alter this list. If I want to add something to the end, I'm going to list.append. An append is the method by which you can add something to a list. So I'm going to print this list twice. Once before the append and once after the append. So you can see what it's doing. Do this, this, and this. So you can kind of get some idea what's going on. So I print the list twice. Once, the first print was before the append and the second one was after the append. And the append simply throws it onto the end. If there's some place in particular I want to put it, I would use the insert method. Insert. We're going to insert 4, and you have to have 2 arguments for this method, function, whatever, they're all the same to me. Let's say we want to put it between the 1 and the 2. So we want to make that the 1 index. So we're going to put 1 Oops. Index and object. And I'm not sure why it did that. Weird little bit. But it's trying to help me. PyCharm's trying to help. So if I run that, you can see the first list is 1, 2, 3, and the second one is 1, 4, 2, 3, because we told it to put it in that second index spot. And if we want to delete an index, we do it a little bit differently. There's a couple of different things you can do. We can do remove. Let's try remove. 3. Remove will take something out, but you have to kind of know what it is. I guess you always will. I don't know. Why is it doing that? It's so weird. So if we put the 2 in here, it's going to search the list, and if it finds 2, it will remove it. You see 1, 2, 3, and then it took out the 2, which is great if you know what's in the list. If you want to delete by index, you would do delete or del list and then the index. So again, we'll remove the 2. So delete and remove, they do the same thing, but you do them differently. I can't think of a reason why you would do one over the other, but again, depending on the programs that you write, each one of these probably has a place. Length, the length of the list. We did length of some other stuff. I think previously length of the string is kind of the same thing. We're going to find the length of the list. So when I run this, it should say 3. It tells me that there are 3 things in that list. And this is very helpful when you have a list that is longish. And we want to know, we don't want to count those. We want the program to do it for us. So instead of saying, you know, let's say we want to do let's make this a variable. A equals length of the list. And then we want to do a while loop. While I is less than A. I'm going to do something. I'm going to print list I. And I haven't declared that yet, so it's like, what are you talking about? So A is the length of the list. I will be equal to 0. So what this is going to do, this is a loop, a while loop. And we did, I don't know if we did a while loop last week or not, but we talked about loops. This is a while loop. And what it's going to do is going to check the value of I, which right now is 0. It's going to see if it is less than A, which is the length of this list. And no matter, that'll change depending on the length of your list, so it's great. So I could put the number 10 in here and it would do the same thing, but you don't really want to hard code that stuff. You want to be a dynamic, and hopefully you're doing something that accepts user input, and then you want the program to run based on that input. So if you hard code 10 and they put it in an 11 variable list, it won't get that last one, or it'll run too many or too few. This way it'll always do the same amount. So if I run this, you'll see, oh, you know what happens? So what am I? I'm in an infinite loop, and I didn't close up this either, so I got to stop this. This is what we call a logic error. Let me zoom in here. It's what we call a logic error. I did a few things. The value of I here never changes. It stays 0. So this loop will run forever. What I have to do is increment that every time it runs through this loop. And it's going to be plus equal 1. So every time it goes through that loop, it's going to add 1 to I. And it should print, yeah, and every time it changes I, so when I change, the first time it goes through, I is going to be equal to 0. So I'm printing list 0 here, which is the 1. That's why I kept printing 1s. And the next time, and then it's going to change the I, it's going to add 1 to 0, so it'll be 1, and it'll print the 2. and it'll print the 3 all the way through the end of the thingy, end of the list, and then it stops because after 10 iterations, I becomes 10, which is equal to A. So it's no longer less than, it is equal to, and the loop stops, jumps out. And that's how you count stuff. If you have a list within a list, how is this going to work? Let's see what happens when we run it. So it's no longer iterating through it's not the length of list. List now becomes 2 rather than the 10 it was before, because it's list within list. If I have to specify an index here. So if it's going to look at the same list again, this list 0 now. Let's see what happens. It goes into an area. It goes out of range. So it can't print list I because why? This is going to change I until it's going to keep incrementing it and trying to increment it all the way up to 10. But I'm only counting list I, which is the first one. It's not, so this I only goes to 2 because there's 2 lists in here where it's trying to go to 10, and that's why I get this list index out of range error. So I would have to do this and give it 2 indexes to count, and then it'll work correctly. And if I wanted to count, yeah, I guess if I just change this to 1 and change this to 1, it'll do the other list in there. 1, 2, 3. So we're iterating through a multi-dimensional array. The bubble sort. Bubble sorts are confusing. We did in, and we already did in and not in. All right, let's do bubble sorts. So we're going to have a list that's out of order. 8, 4, 5, 1, 3, 6, 9. All right, we got a list here. It's all out of order. And we want to sort it. So how we're going to do that, we're going to have to count it a couple of times in a couple different ways in a couple of different loops, and we're going to compare each index to the index after it. And if the index after it is smaller, then it's going to have to swap the 2. So we're going to do that. So if that amazing explanation wasn't enough for you, here's an illustration of what I mean. You're going to have to count through this thing a few times, or you have to count through the list a few times, and it's going to look at 2 indexes at the same time, one right next to each other, like the 5 and the 1. If the 1 is smaller than the 5, it's going to move it over, and then it's going to keep going through, moving. It's going to concentrate on this first 5, and it's going to move it as far back as it can until that condition is not met, where it's larger than the one behind it. Then it's going to go through and look at the next index, and it's going to move that 4 back. And then it's going to go look at the next index and the next index until it finds one, or it gets to a point where it's done. So let's do that real quick. It's kind of confusing. This is going to be a mess, especially if you've never seen it before, but we're going to count through it twice. So for I in the range, the length of the list, hope I explained what that does good enough earlier. We're going to do -1 because we don't want to include the last index on there, because you can't compare the last index. Hopefully it should be the biggest number. If they all get pushed through, it should be the biggest number by the time the algorithm gets to it, and you can't compare it to something behind it because there is no further index behind it. But then we're going to do another loop, and we're going to call this J, and it's going to be the same length, or the length of the list, minus 1. And every time we go through, we're going to check and see. Oh, I got to put my semicolons in there. And every time we're going to go through, we're going to check and see if the list with the index of J is greater than the list item with the index of J plus 1. So the one just after it. We're going to see if it's bigger. If it is, we're going to assign that to a temporary variable, and we're just going to give that the value of list J. Then we want to swap the two. Oh, I got to put a semicolon in there. And I got to put an in here. That's why I'm getting a red mark. Getting red marks, something's wrong. So we're going to swap these values, and we need to hold the value of J in a temporary variable just for the swap. And then list J is going to become the value of list J plus 1. So we're moving the plus 1 into just the J. And then we change the list J plus 1 to equal the value of that temporary variable. So that's the swap. And what I'll do here is I'll print this list before we go through the whole bubble sort, and then I will print it again after. And I keep forgetting to change this to close up. I know you can't see it, and I apologize. So here's my code. Well, we're going to go through the list, the length of the list, and then we're going to go for each item in that list a second time, because we're going to compare the two variables. So it has to take the one variable. The first time, like I said, it was going to go through that 5. I think I may have closed that picture. This first, man, I got to keep going back and forth. So the first time we go through the code, the first for I in range is going to take this variable, and then it's going to compare that I to J, which is every other index in that list. And then it's going to go back and start over again. I compared to all the J's. I compared to all the J's. I hope that makes sense. I know this is confusing, and it's always confusing to me. But if I run this, you can see, if I close this up, you can see how the first list was out of order and the second list is now in order because we did this swap. So I encourage you to play with this a little bit, and you will have an assignment, I think. No, maybe not. I'm not sure if you'll have one of these in your labs. But you will deal with lists in your labs. But this is a bubble sort. And again, if you're taking any other coding classes, it's going to be the same thing. You're comparing two indexes and then swapping the values while in this loop. So I know that's confusing, but there it is. What else? Slices. In or not in. I kind of covered this a little bit. Slicing. That's what I was doing earlier. So if I want to print just a slice of the list, I print from 2 to -1. That's what I was doing earlier, and it's a slice. So it's going to print 0, 1 from the 2, 3, 4, 5. And not the last variable. It's not going to include this last one. And then, like, if I just want 2 to 3, that's a slice. It doesn't include the third index, just the second one. If I leave this blank, if I put 2 to semicolon, it should go all the way to the end. And conversely, if I don't put anything in the front, it will print from the front to the whatever variable, whatever index you say. So we should get 5, and this is 8, 4, 5, 1, 3. Yep. 0, 1, 2, 3, 4, and does not print that last one. It's not inclusive of the 5th index, but it'll print everything before that. So that's the lesson. I hope this video wasn't too long, and I hope I didn't talk too fast. But again, if you have any questions, please email me. I can cover it slower or more in detail, whatever you need me to do. For your assignment, like I said, you will have these screenshots to do. For your student grades assignment, this is going to be your assignment in PyCharm. You need to use this variable here. This is a multi-dimensional variable. I think if you open this up, it looks better. No, it's bigger. This variable here is your multi-dimensional variable for grades. And what we're going to do is we are going to have a list of students and these are the grades. What you need to do is create a program that does these things, and there are 5 things. So it has to create a list variable you have to create a list variable containing 5 student names, and I don't care what they are. Student 1 to 5 is fine. You need to take this variable that I gave you here, count through it, and find the average for each of the 5 students. So these aren't all equal variables. You can see some are long and some are short. So remember how to index a multi-dimensional variable, and then you will have to perform a calculation on that, and it's just simply dividing by the length. So to get an average, you all know how to get an average. You add them all up and you divide by the number of grades you had. If you have 10 grades, you add them up, divide by 10. So you're going to have to divide by the length of this index. You're going to have to count it and then divide by that number. And then you're going to prompt the user for the name of the student. So you should be able to accept an input. And I should be able to put student 1 in there and hit enter, and it'll show me the grade for student 1, the average grade. Your output should look something like this or better. Some of you like to do better, and I appreciate that. If you have any questions, please email me early on in the week and we can get through this. This is not that difficult, but you do have to understand the material. So again, email me if you don't get something. And good luck.